Hello and welcome to lesson 6D on rational exponents. So let's take a minute and recall all of our laws of exponents. We have two numbers of the same base. When they're multiplying together, you add their exponents. When you raise two numbers to a power, you apply that power to both of the bases. When you have a power raised to a power, you multiply your powers together. When you divide two numbers of the same base, you end up subtracting their exponents. And when you divide two numbers but raise them to a power, you still raise both of them to the power while still dividing those numbers. So these laws also apply to rational exponents. And a rational number is a number that can be expressed as a fraction. So just because we have a fraction now in our exponent doesn't mean any of our rules still change. So a to the 1/2 times a to the 2/3, because we have the same base, we're going to add our powers. 1/2 plus 2/3. And we learned way back in middle school that if we add fractions, we need common denominators. Common denominator would be 6. This becomes 3/6 plus 4/6, or this is a to the 7/6, which doesn't reduce anymore. When we've got power to a power, we multiply our exponents. This is x to the 2/3 times 3/4. I like this one because the 3's cancel and the 2 and the 4 are going to reduce. So this just becomes x to the 1/2. And when we divide, we simply subtract our exponents. This is n to the 1/5 minus 7/10. Well, whenever we subtract, we need common denominators. So this is n to the 2/10 minus 7/10, or n to the negative 5/10. I can reduce that fraction. That's n to the negative 1/2. And we learned that if we have a negative exponent, we have to flip that into my denominator. So that's 1 over n to the 1/2 would be my final answer there. All right, I want you guys now to pause and try these next three on your own. Okay, go ahead and check your work. Again, when we're raising power to a power, we distribute that fourth power to all three. And be careful, guys, multiplying by a whole number is the same thing as multiplying by that number over 1 when you're dealing with fractions. So let's take a look at some examples now where we're going to multiply some polynomials together. Remember, we have to distribute to both of these, and what happens, this becomes z to the 2/3 times z to the 1/3, or z, we add our exponents to the 2/3 plus 1/3 minus, again, we multiply again, this is z to the 2/3 plus 5. This one's pretty easy. This becomes z to the 3/3 minus, here I need common denominators. This is z to the 2/3 plus 15/3. This guy, 3 over 3, just becomes 1, so that's z minus z to the 17/3. Here you have to FOIL. We go front. That means we're going to add our exponents. 1/3 plus 1/3. Outside, plus 2x to the 1/3. Inside, negative 5x to the 1/3. Last, minus 10. These guys can combine because they're like terms, and this becomes x to the 2/3 minus 3x to the 1/3 minus 10. Go ahead and do this next question on your own. Okay, go ahead and check your answer. All right, now here's something that's pretty interesting and new. Expressions with a fractional exponent actually can be written as radicals. So if I have a to the 1 over nth, what this really can translate to as the nth root of a. The denominator in your fractional exponent becomes the index of your radical. And this only applies if n is a positive integer. So if we have the 4 to the 1/2, that's the same thing as the square root of 4, which is really 2. And 64 to the 1/4 power to the 1/3 power is the third root of 64, which ends up just being 4. And here I have negative 9 to the 1/2. Well, the negative is not in parentheses, so it hangs outside the square root of 9. So the square root of 9 is 3, so I get negative 3. Here I have the fourth root of 81x to the 8th. Well, the fourth root of 81 is 3, and the fourth root of x to the 8th is just x squared, so I get 3x squared. And here we get the cube root of 5y, which actually can't go any further, and that's as good as that gets. All right, guys, take a minute now and do these 4 problems on your own. Go ahead and check your answers. All right, so what does 8 to the 2/3 mean? Well, there's actually 2 ways to interpret this. The first is to look at it as 8 to the 1/3 power times 2, or as we were looking at this would be the cube root of 8 then squared. Well, the cube root of 8 is 2, and 2 squared gets me 4. But there's another way to do it. We could also think of this as 8 squared to the 1/3 power. Well, 8 squared is 64 to the 1/3 power, which is the same thing as the cube root of 64, which we all know is 4. So going 2 different roots, we get to the same answer. So a to the m over n can translate 2 ways, either as the nth root of x to the m power, or as the nth root of x to the nth power. Usually it's easier to calculate your radical first, to do the radical first and then raise that to a power, because you're making a number smaller before making it bigger, rather than going the other way around. But you will get to the right answer no matter which way you go if you work it properly. So let's look at some examples here. Let's rewrite these in radical notation and then simplify. So 16 to the 3/2, my denominator is my index, so that's a square root of 16, and my numerator is my exponent cubed. I'm doing on the outside because it'll be a lot easier. The square root of 16 is 4 cubed, and 4 cubed gets me 64. So here I've got a negative. This is not in parentheses, so my negative just sits out front, negative. My denominator here is is 2, so it's going to be a square root of 25. My numerator is 3, so square root of 25 cubed. I get negative. The square root of 25 is 5. I'm then going to cube it. I'm really going to keep that in parentheses so I don't mess up the negative here. 5 cubed is 125, so I get negative 125. Now my negative is in parentheses. This one's a little bit different. My denominator is a 3, so this is the cube root of negative 64, and my numerator is a 2, so square it. The cube root of negative 64 is going to get me negative 4, and when I square that, I'm going to get positive 16. And then here, my denominator is a 3, so I put the 3 here, and I put negative 27 x to the 6th. Again, the negative's inside parentheses. All that's going to be squared, so let's do the cube root part first. The cube root part of negative 27 is negative 3, and the cube root of x to the 6th is x squared, and I'm now going to square that to get 9x to the 4th. And let's do the next one here. My denominator is a 2, so I'm going to do the square root of 9a squared. My numerator is a 3, so we raise all that to the 3rd power. The square root of 9a squared is 3a. I then cube it. Well, 3 cubed is 27, and then I have a cubed. And here we have to a 4th power. This will not be able to simplify more than a rewrite. My denominator is a 4, so I do the 4th root of 4x minus 5, and then all of that's going to be cubed. All right, so I want you guys now to do these 5 trimies. All right, guys, go ahead and check your answers to those 5 questions. All right, now don't forget about your negative exponent rule. If I have a negative, we always flip it, and when we flip it, we flip the whole thing, including the fractional exponent. So 16 to the negative 3/4, I'm always going to flip first. So this becomes 1 over 16 to the 3/4. Then I'm going to rewrite that as a radical. So it's 1 over the 4th root of 16 cubed, or 1 over 4th root of 16 is 2, still cubing it, or 1 over 8. So if we have negative 27 to the negative 2/3, well, the negative exponent flips it. 1 over negative 27 now to the positive 2/3. We're going to rewrite as a radical. 1 over, that's the cube root of Because the negative's inside parentheses, it goes inside the radical, negative 27 whole quantity squared. Well, the cube root of negative 27 ends up being negative 3, which I'm now going to square, so I end up with 1/9. I want you guys now to try the next two. All right, guys, go ahead and check your answers here. Okay, so now we can actually use radical exponent or rational exponents in order to simplify our radicals further. So what I want to do on these, I actually want to rewrite these in rational exponents and simplify from there. So the 8th root of x to the 4th is really x to the 4/8. Well, 4/8 can simplify to be x to the 1/2, so that's really just the square root of x. It's a much simpler thing to write. Here, I'm going to rewrite the 25 as 5 squared, and then rewrite those as a fraction exponent. So I get 5 to the 2/6, which is really 5 to the 1/3, or the cube root of 5 ends up being my final answer. Here, I'm going to rewrite both of these as fractional exponents. I get r to the 2/4 times s to the 6/4. I want to keep these denominators the same. Both of these can reduce by 2 to become r to the 1/2 and s to the 3/2. Again, I want those denominators the same so I can take that back to one radical. It's the square root of rs cubed. So go ahead, guys, and do these 3 trimies on your own. So before moving on, I want to point out one thing. Right here, this 4/8 to the, and bringing that down to 2/4, I didn't take that all the way down to a 1/2 on purpose, because I wanted to make sure that both of these numbers could end up under the same radical. So these denominators had to be the same. So I made them both over 4 on purpose. So that was my logic in approaching that problem. All right, guys. You can also use radicals or rational exponents to help you take 2 radicals with different indexes and combine them together. And you do that by rewriting these as rational exponents. This is x to the 1/2 times x to the 1/4. And as we went over at the beginning of this lesson, when I multiply things like this, I simply add their exponents. That's x to the 1/2 plus 1/4, which becomes x to the 2/4 plus 1/4, or x to the 3/4, which means I could rewrite this as a radical as the 4th root of x cubed. Here, when I am dividing the radicals, I'm going to rewrite them again as rational exponents, x to the 1/2 over x to the 1/3. I'm now going to subtract. This becomes x to the 1/2 minus 1/3, or x to the, we're going to make that over 6, 3/6 minus 2/6, or x to the 1/3. So this is simply the cube root of x. And then here we've actually got numbers now. We can still do this. I'm going to rewrite these with rational exponents. This is 2 to the 1/3 times 2 to the 1/2. We add their exponents. This becomes 2 to the 1/3 plus 1/2. 1/3 plus 1/2 becomes 2 to the 2/6 plus 3/6, or 2 to the 5/6, which means we can rewrite this as the 6th root of 2 to the 5th power. I want you guys now to do these 2 trimies. You should have gotten the 15th root of y squared. Now this next problem is different because if you notice, you do not have like numbers inside your radical. We're not really used to that. And we have unlike indices. So what we're going to do is we're first going to write these as rational exponents. This is 5 to the 1/3 and 3 to the 1/2. If I can get common denominators on those fractional exponents, then I can write them under one radical and go from there. So a common denominator here would be 6. So this is the same thing as 5 to the 2/6 times 2 to the 3/6, which means I could now rewrite them under one radical, the 6th root of 5 squared times 2 cubed, Well, I can go further than that. This is the 6th root of 25 times 8, and 25 times 8 is 200. So I get the 6th root of 200 as my final answer here. All right, guys, we're at the end of the notes. Good job. Please take a look at the practice assignment.